Hello everyone, this is example 5 from array, and in this example a code segment is given to us and we need to evaluate this code segment and we need to find the result that will produce by this code segment after its execution. So let's start with execution of the given program. So this is our main function, that means control execution of this program from this entry point function. Now this is the array declarative statement, and in this array declarative statement the storage class is not specified by the programmer. That means here default storage class will use by the system, and default storage class is auto. Now when we declare any variable with auto storage class, at that time memory of that variable will allocate from stack section. Now so this is our stack section in memory, and from this stack section a memory block will create for this array AB, and in this AB array no range is specified by the system, by the programmer. So how much memory block will allocate for this array, and that depends on the initialized data. Now how many elements are there in the initialization? Only 3 elements they initialize for this array AB. That means for this AB array total 12 bytes of memory will allocate for this AB. The index will be 0, 1, 2 because here only 3 elements specified in this declarative statement. Now the first element will be 10, second element 20, third element 30. The base address let's consider is 2011, and the AB, that means our array name, will contain the base address 2011 and the address of AB will again 2011. That means this AB will pointing to this, the base address of this memory block. Clear? Now coming to the next statement, the next statement is given as int I. Here also no storage class is specified. That means again memory will allocate from stack section, because here also the storage class is default storage class. That means what? That means auto storage class. So from this stack section one more memory block will create for the variable I. Let's say the base address of this memory block is 2030. Now here no value is initialized in this declarative statement, so the initial value will be garbage value. Now in this for loop, the value of I is initialized to 0, so the value of I will update to 0. Now the next statement is condition. What is that condition? The condition here is I greater than 3. Now what is the value of I? The value of I is 0, 0 greater than 3. That means condition is true. So after system gets the condition is true, it enter inside the for loop and execute the first statement. Now in this statement this is a printf statement. That means this will give us the output. So let's consider this is our output. Now %d, then identifier here is asterisk AB. So here it encounters AB star. Now what does it mean? This means the content of AB. What is the content of AB? The content of AB is 2011. So here it will get 2011 and then indirection operation. Look, this 2011 is the address. That means control directly come to this address, and when control encounter this indirection operation, at that time it enter inside the block, that means first element, and then it retrieve the first element from the memory. And what is that? That first element is 10, so it will give us 10 as result. So this 10 will be displayed here. So the output for this printf we get is 10. Now the next statement. The next statement given as AB++. That means here we get AB++. This is a post decrement operation, but this post decrement operation is a independent expression. That means this control simply execute this post decrement operation. Clear? Now how system will evaluate this expression? It is result as AB equal to AB plus 1. Now look at here. we are updating the value of AB. Now what is that AB? AB is the array. AB is our array name. Now we know whenever we declare any array, at that time the array name is a constant pointer. That means this is a constant pointer. What does it mean by constant pointer? Constant pointer means it is not allowed to any programmer to update the content of array name. Now here we are updating the content of array name. What it will give us? It will give us an error because we are trying to update a variable that is defined as constant. So here, because of this instruction where we are trying to update the array name, and array name is internally defined as constant pointer, because of that this program will give us an error. Clear? So for this program, for this particular program, we will get output as error message. Clear? So this program will not produce any output in this particular scenario. Now how we can resolve this problem? Look, instead of updating this particular array name, if we declare an integer pointer, let's say p, and p is initialized with the content of AB, and here we are printing the value AB and we are updating the pointer p only. At that time we will resolve the problem whatever we get in previous case, and that is error message. Clear? Now how system will evaluate with this modification? Let's see that thing. Now in this form of code, till this statement same, the next statement where we declare I, that I will initialize with garbage value, that is also same. Now look, now here in this case, how we declare this particular memory for this particular array declaration, it is this one is exactly same. We start work with the next statement. In next statement we declare a variable I, that means memory will create for the variable I. Let's say the base address is 2030 and it will initialize with garbage value, and there is no value specified for this variable. Now the next statement is we are declaring a pointer variable, and let's say this is our pointer variable p, and let's say the base address of p is 2040 and the variable p is initialized with AB. So what is there in AB? In AB contains 2011, that means p contains 2011 here. Now this p is pointing to the same base address of the array. Clear? Now look, this is not a constant pointer. P is not a constant pointer. Even though it is holding the base address of the array, it is not a constant pointer because this p is not declared as array. It is declared as only as a integer pointer. That means a pointer that will hold the base address of an integer. Look here, in this is the whole memory is allocated for array, correct? But the first element is just a integer. That means this p is containing the base address of this particular integer only, not containing the base address of the whole array. This 2011, whatever p is holding currently, that base address is just for the first element of the array, not for the whole array. Clear? Now coming to the next statement. In next statement we initialize the value of I with 0, and then the termination condition is I greater than 3. The value of I is 0, so 0 greater than 3, this condition becomes true. Now as this condition becomes true, control enter inside the for loop and print this particular instruction. Now what is there in p? P contains 2011, that means this particular address. Now because of this asterisk means indirection operator, control enter inside the block and retrieve the value 10, and that 10 will display here in case of %d. in place of %d, and then system encounter \n, so control come to the next line. Clear? Now the next instruction is p++. Now look at here, p++. This is again a post increment operation, but this post increment operation is independent, so system directly evaluate this post increment operation, and that is p equal to p plus 1. Now look here, p is a pointer, and here 1 is an integer value. That means this addition operation belongs to pointer arithmetic. So how system evaluate pointer arithmetic, we already know that thing. So here the content of p is 2011. So here the value of p will be 2011 plus 1 into size of, what is the size of data, and what is the data type here? The data type here is int. So here the size of int will come. Now what is the size of int? That is 4. So here it will give us 2015. Now the content of p will update it to 2015 because this 2015 will store in p. Now this p will hold 2015. Now again this is the base address of next address 2015, then 2019. Again this 2015 is the base address of the next element, that means second element in the array itself. So this p is pointing this particular element now. So after evaluation of this particular instruction, control jump to the third part inside the for loop, and that is increment the value of I. Now increment the value of I and it becomes 1. Now after increment, control come to the termination condition, and now the termination condition becomes 1 greater than 3, and that is again true. So control enter inside the for loop again. Now in printf %d*p, that means what is there in p? P contains 2015 now, and because of this indirection operator, control enters inside the element, inside this address 2015, or inside control enter inside the memory block that is represented by this particular address 2015. Now control what it will get? It will get the value 20, and this 20 will display by the printf. After display the 20, control \n is there, so control comes to the next instruction. After that control come to this particular instruction p++. That means again this instruction will evaluate. And how this instruction will evaluate? This instruction will evaluate as p equal to p plus 1. Now what is the value of p? The value of p now is 2015 plus 1. That means 1 multiplied by size of int, that is 4. So it will give us 2019. Now this address will store in the variable, in the pointer variable p. So now the 2015 will removed from p, and new value 2019 will store in p. Now this p is pointing to this particular element, that means the base address of the third element in the array. Clear? Now after completion of this instruction, control jump to the third part in the for loop. Now this is the increment instruction, so it will increment the value of I. Now the condition is 2 greater than 3, and this condition becomes true again. So control enters inside the for loop, and the first instruction is printf %d in direction of p. Now where p is locating? P is locating this particular address, and indirection means enter inside the block. So control enter inside the block and get the value 30, and that 30 will display here. So here we will get 30, and then \n, that means control come to the next line, and then p equal to p plus 1. Next instruction is p++, that means this particular instruction will evaluate again. Now the content of p is 2019. So 2019 plus 1, and then size of int. So what is the size of int? The size of int is 4. So here it will give us 2023. That means here 2023 is the next address in the memory block. Clear? Now after evaluation of this particular instruction, this value will update to 2023. Now control again switch to the third part of the for loop. So now the value of I will again update it to 3, and then this particular statement, that is 3 greater than 3, now this condition becomes false. When this condition becomes false, control come out from this loop and encounter the next instruction, that is closing brace for the main function. That means this is the end point of our entry point function, and this is also the end point of our program execution. So the program execution is completed, and this is all the memory that allocated by the system while executing this particular program, and these all are processing part what system work with at the time of execution of this particular program, and this is what we get after execution of this program as result or output of this particular program. Clear? So look, in our previous version of this given program where we are trying to update AB, that means our base address of array, at that time system gives us error, but when we remove that modification instruction from our code segment, we replace by a simple pointer. At that time system execute with the program without any error. Clear? And we get the result as this one. So you need to remember this particular point. Whenever we try to execute or we try to update the base address of any array, at that time system will give us error. But if we store the base address of an array into any pointer type variable, at that time we can easily modify that pointer, because that pointer is no longer a base address of any array, due to that reason we can modify the pointer content itself. But in case of array, we can't modify or update the base address of any array. Clear? So that's it for today. See you soon in our next class. Thank you.